Welcome to qnawire.
In this problem, we want to determine the exergy destruction associated with the regenerative cycle in problem 45. And we have a high temperature side of 1500 Kelvin and a low temperature side of 290 Kelvin for the heat transfer. And so the thing is that it's actually very easy to find the cycle exergy destruction because if we just draw a control volume around the whole cycle, then we have heat going out, and heat coming in. And the entropy is all basically internal. So the net change in entropy in this internal process here is zero. So if we only have heat coming out at the turbine, or I mean, sorry, at the boiler and the condenser, or you only have heat flow at the boiler and the condenser, the change in entropy is just the change for the because of the heat transfer um, over these different temperatures here. And so we have the exergy destruction is just the heat transfer out of the condenser across this low temperature, minus the heat transfer in to the boiler, minus the divided by the high temperature. So we actually calculated these back in that problem. So to get this, again, we're going to assume T low, T naught is T low. So to get the exergy destroyed in the cycle, or the specific exergy destroyed in the cycle, we just need to, it's a very simple calculation. And that's T naught times the exergy, or the entropy generated, entropy change from the heat transfer, and then from the heat transfer out, and from the heat transfer in. And again, we have a minus sign here because we're basically taking these to be both positive. So we just plug everything in, and we wind up with an exergy destruction for the entire cycle of 1,155 kilojoules per kilogram.